Morning.
Morning.
Jack, did you get my email? I can't hear you now.
Yep, I saw it.
Okay. Jack, is that your dog?
No, that one's not me.
You have a dog?
I have two dogs.
Really? What kind are they?
They're both Newfoundlands, so their names are Yogi and Boo Boo. Like
Oh.
Yogi.
Yeah, if I were to get, when Rosie passes away, I'll bring Rosie in someday. But when Rosie passes away, I'm not going to get another dog. But I'd really like to get, I always thought it was Newfoundland. But how did you pronounce it?
So like we looked it up when we got them, but there's like a debate on which way you're supposed to pronounce it, so they're not really sure.
Yeah, they look really gentle.
Yeah, they are. They're super playful when they're really young, and then they kind of just get really docile as they get older.
Yeah. A lot of hair.
Yeah, a ton of hair, and it gets super knotted up, so you have to take them in to get haircuts a lot.
Okay. How old are they now?
I think Yogi is 5. He's the older one, and then Boo's like 10 months old probably, and he's already bigger than the other one.
Okay. All right. You know what I haven't been doing, and I've been getting in trouble for it. So I'm going to have to do it today. I have not been taking roll. And they'll probably fire me. So give me a few seconds here. All righty. Is Cole present? I got some people waiting here. Cole's one of them, of course. Cole, you're here, correct? Cole?
Hello.
Okay. Haley? I should be here in a second, I'm sure. Maybe what I should do is just. Haley, are you here?
I'm here.
Okay. Heidi?
Here.
Morgan?
Here.
Noah?
Here.
Oh, right. God, you scared me there for a second. Bryn, I saw Gus. Kathy here? He is now. Okay. Zach?
Here.
Christian?
Here.
Nick?
Here.
Olivia?
Here.
Noah?
Here.
Dom?
Here.
Ari?
Here.
Jack?
Here.
Bryce?
Here.
Jacob? Do you go by Jacob or Jake?
I go by either. I don't really care.
Okay. Darcy?
Here.
Cora? Cora? She's here. Kaya?
Here.
All righty. Good. I'm done with that. So they're all present. Let's see. Okay, we get rid of you. All righty. So I'm hoping everybody got the results. Am I right on that?
Yeah, I did.
Okay.
Yes.
Okay. So I am going to, so what's going to happen is I'm going to go through the test. Okay. And if you have anything you want to discuss with me afterwards, we will do it at that time, okay? So that's the way I prefer, as opposed to having 20 interruptions that I go through. So you want to make sure that you're seeing your work and how it's looking at my work. If there is some type of clarification that you want to see, you can ask. But if you want to discuss a change in the scoring, just let me know afterwards. Does that work out for everybody? So, okay, I'm going to say yes, it does, because that's what we're going to do. I've never done it this way. It's a lot easier in class, but we will see how this works. So I'm assuming this is your test that we're talking about, correct? Jack, does that look like the one?
Yeah, that looks like the right one.
Okay, so this is how I would start. This would be me taking the test. Hope I got enough ink in this pen. So this is the non-calculator portion. I do this, I draw the unit circle. And right here, this point is 1, 0. This point is 0, 1. And then I have these dots right here. So this is pi over 6. Well, I'm going to do it this way. This is pi over 6. This is pi over 4. This is pi over 3. And this is pi over 2. Now those are angle measurements. They are not any of the answers. So none of your answers should have pi in them. They're going to be either these numbers 1 or 0, one of these. And so x is equal to the cosine of theta, y is equal to the sine of theta. And so what I do is I look at this as the square root of 4 over 2 comma 0, because that's the same as 1. And then this is the square root of 3 over 2. And this is the square root of 1, or 1/2 over 2. And then this is the square root of 2 over 2, square root of 2 over 2. And if you notice, this goes 0, 1, 2. So this next one's got to be the square root of 3 over 2. And this goes 4, 3, 2. This has got to be the square root of 1 over 2, which is 1/2. So I write those ordered pairs in there. But that's the way I look at it. 0, 1, 2, 3. Here's the square root of 4 over 2. And then 0, 1, 2, 3, 4. I don't know, have you ever seen that before? So I've got pi over 6 and its sine. So it's going to be 1/2. Pi over 4 is square root of 2 over 2. Tangent of pi over 3, it's sine over cosine. So it's going to be the square root of 3 over 2 divided by 1/2. Now I'm going to show you something that, remember when you guys are told take every division, right? Because tangent is sine over cosine, or sine divided by cosine. Am I going too fast on that? Well, you can write it as a fraction, you can write it as a division. And a lot of teachers say, hey, or math teachers say, you've got to multiply by the reciprocal. You could simply divide straight across. And this gives me the square root of 3 over 1, which is the square root of 3. I find that a lot faster. The sine of 0 is 0. The cosine of 0 is 1. The sine of pi over 2 is 1. The cosine of pi over 2 is 0. The tangent of 0 is sine over cosine, so it's 0 over 1, which is 0. Oops. Pi over 2 is undefined. And the cosine of pi is way over here. And this point is a -1 comma 0, so it's going to be a -1. And those were all 1 point. The next 4 were worth 5. So I think what I did is if you got something major wrong, I just took off 2. So right away, the cosecant, oh, excuse me, each of these were worth 2.5. I'm sorry, not 5. So the cosecant of theta is equal to 4/3 because it's the reciprocal. What I did here is I made a right triangle. Here's theta. Sine is opposite over hypotenuse. So this is going to be the square root of 16, which is 4 squared, minus 9, which is 3 squared, which is the square root of 7. So my cosine is going to be the square root of 7 over 4, which means my secant is going to be 4 over the square root of 7. In AP Calc, you never have to rationalize the denominator. A lot of you did because, you know, they teach you to do that. In AP, it takes time, so you'd never have to simplify or rationalize the denominator. The next one is tangent of theta, and that's going to be 3 over the square root of 7. And the cotangent of theta is the square root of 7 over 3. The next one, again, I have a right triangle. I guess I'm going to do secant. That's going to be 4. Here's theta. It's adjacent over hypotenuse. And so this is going to be the square root of 16 minus 1, which is the square root of 15. So that means sine is equal to square root of 15 over 4. Cosecant is equal to 4 over the square root of 15. Tangent is going to be the square root of 15 over 1, or square root of 15. And cotangent of theta is going to be 1 over the square root of 15. Now, I'm going to tell you an interesting story. When I was a senior in high school, I got injured and I was in the hospital for the first quarter of the school year. So September, October, I think I came back in November. So I had to learn trig by myself. So when I got back, you know, I want to impress my friends that I knew what was going on. So when they talked about trig, I used these words. I called that, rather than cosine, I called it cos, tan, sec, cot. And what made my friends really enjoy is I called this ksk. So the rest of my life, I was known as ksk. And so when we have a class reunion, everybody yells out, how's life? Ksk. Because that's how I thought it was pronounced. Just a little random thought. All right. Tangent. I'm going to write cotangent here. 3 over x. Here's theta. And so this is opposite over adjacent. And so this is going to be the square root of x squared plus 9, which is not x plus 3. That would be voodoo math. And so now this cosine is going to be 3 over the square root of x squared plus 9. The secant is going to be the square root of x squared plus 9 over 3. The sine of theta is going to be x over the square root of x squared plus 9. And the cosecant is going to be the square root of x squared plus 9 over x. We do this again in the second trimester. We'll come back to this. So secant of x, this is x over 1. Secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent. So there's x, there's 1. This is the square root of x squared minus 1. So that means the cosine of theta is going to be 1 over x. It means the sine of theta is going to be the square root of x squared minus 1. The cosecant of theta is going to be 1 over the square root of x squared minus 1. The tangent of theta is going to be, oh, excuse me, I screwed up here. This should have been over x, and this should have been x. I'm sorry. The tangent of theta is the x squared minus 1, and cotangent of theta is equal to 1 over the square root of x squared minus 1. Any questions on those? And I'll move this up. So the first thing I did is I looked to see if you got the hypotenuse correct. Everybody seemed okay on the ratio part. Then the true and false. This is not true. That's false. And you can put in the square root of 4 plus the 9, and that will give you the square root of 13. It is not equal to 2 plus 3. It's not equal to 5. This is also false. This symbol, it's called an even root because there's really a 2 right here. So if I would have the 4th root, if I would have the 6th root, if I would have the 8th root, any even root must be positive by definition. It cannot be negative. So that is false. However, this is asking a different question. It's asking you what number times itself gives you 36. Well, 6 does, but so does a negative 36. Excuse me, a negative 6. So this is true. Simply this radical sign, this even root radical sign, gives you what we call the primary root, which must be positive. However, this squared says, and if you graph this, the graph is a parabola that looks like this. There are 2 values up here that are 36. One is made by 6 and the other one's made by a negative 36. I guess this is not the correct graph. It'd be way down here. Something like that. This is true. This is false. This is undefined because you can't divide by 0. This one. So I'm going to do long division. So I have a cubed. I'm going to put plus b cubed over here. And I'm going to multiply by a squared. This gives me a cubed plus a squared b. Have you guys ever done long division? So what I do is I'm terrible at subtraction, so I add the opposite. There's a big 0 here. So I'm going to get a negative a squared b. So I'm going to multiply by minus ab. Excuse me, minus ab. And I'm going to get a minus a squared b, and then a minus ab squared. I'm going to change the signs and add. And I'm going to get ab squared. And I'm going to multiply this by b. Excuse me, I get, I'm going to multiply this by b squared. And I'm going to, when I multiply these two, I'm going to get ab squared. And when I multiply these two, I'm going to get cubed, subtract, and I get 0. So this is factorable. This is called a binomial cube, and a binomial cube always factors to this. So this is true. This, they're both undefined. However, they mean something different. So here's the idea. If I have 2 times 4, it gives me 8. That means 2 is equal to 8 divided by 4, correct? Well, if I have 8 divided by 0, and I say it's equal to some number, I'll say that it's C. That means 8 has to equal C times 0. Well, is there any number you can multiply by 0 to give you 8? There isn't any, correct? There are no answers to make this true. So this is always, this can never be, there is no number that works. However, if I have this, 0 times 0 is equal to C. Well, that means C is going to be multiplied by 0. Every number works. So the reason we call this undefined is we don't know what number C is. In calculus, we actually figure out that C. And we use a method called L'Hopital's rule to figure out that C. So this is false. All right, any questions on that portion? Something I need to clarify? All right, doesn't look like it. All right, next part. So this is, it says we're asking about F. If I look at the graph of F, it's a parabola that's been slid up 1. I can put any number that I want in here, and I didn't tell you the notation that I wanted. A lot of people, some people went like this, from negative infinity to negative infinity. That's perfectly using open intervals. Some people did it this way, x such that x is an element of the reals. That works also, okay? The range, however, and I'm going to write it this way. I'm okay with if you wrote it in interval fashion. I'll write it in interval fashion too. Y such that y is greater than or equal to 1. You could have done this, I suppose. Bracket 1 to infinity. If you did write it this way, you had to have the bracket. I think I took off a half a point. This one was worth 2 points. This is also worth 2 points. This is simply a line, so you can input anything you want. So you can go from negative infinity to positive infinity. Here you're going to get negative infinity to positive infinity. Here you're going to add them, and you're going to get x squared plus x plus 3. And so if you graph this, we talk about how to figure out what the vertex is, because this is going up. So the vertex is the lowest point. It's the lowest y. So here I'm going to have negative infinity to infinity. I can put everything, but my results aren't going to be that way. So when you do that, and in calculus, there's a quick way to do that, but I'm going to do it by graph. Oops, I got too much stuff here. And so this right here is where the vertex is. And you can do this on a Casio too. Here you go simply shift G solve and look for the minimum value. And Casio does it quick. The smallest Y value you can have is 2.75, which is not 3, by the way. So I can go from 2.75 and higher. Have you guys learned how to use the minimum and maximum button on your TIs? Should I review that on your TIs? Would you like to see that?
Yes.
Okay. Thank you for taking a risk and saying something. Okay, let me find my TI. It's a little different on the TI. Y equals clear x squared plus x plus 3 graph. So there's the graph. You can see right here, there's the minimum point. Right here in yellow, at least on mine, I'll tilt it up. I don't know if you can see it. Right above the trace, it says calc. So I'm gonna go second calc. And one of my choices is the minimum point. So I'm gonna type in 3 and it's gonna minimum point. It says left bound. Well, what they want you to do is be a little bit to the left of the vertex, and then you're gonna press enter. And then they want you to be a little bit to the right of the vertex. I'm gonna press enter. Then I want you to guess. I never guess. I just type in enter. And it will tell me that my lowest Y is 2.75. And so you're gonna get the same answer. The next one, you have to multiply them together. So if I took x times, I took x squared, excuse me, times x and got x cubed. And then I took x squared times 2 and got 2x squared. And then I took 1 times x and got x. And then I took 1 times 2 and got 2. Well, that's a cubic function. It's odd, isn't it? So since it's odd, it means there's no turning around point here. You could graph it and saw the same thing. So it's going to be all the reals, both for the domain and the range. Over here, I'm going to have the function. This one, by the way, was worth 3 points. This is C, D, and E were all worth 3 points, and so was F. So here I have division, and so I'm going to have x squared plus x over x plus 2. And so I know that I wrote it this way, x such that x is an element of the reals, and x is not equal to a -2, because you can't divide by 0. So I need to see that somehow. And then I went through and I graphed this in the same fashion that I did the previous one. So I'm going to put that in here. And I'm going to have x squared plus, what was it, 2 plus 1 divided by parentheses x plus 2. And I get something that looks like that. So I'm going to draw it. Okay, well, first of all, I can see there's a maximum point here and a minimum point here. Here is where my asymptote. And what's nice is if you choose to on a Casio, I can put in that asymptote. I'm going to put in a -2. And you actually, I think you can do that actually on a TI. In fact, I know you can. So there's my asymptote. And then right here is going to be a minimum point. Right here is going to be a maximum point. So I'm going to go G solve. And my minimum point is going to be 0.472. Now, some people put in 0. Well, that's not accurate enough. And if some people put in 0.5, I think I let that go by. If some people put in 0.47, I think that let go by it, but I can't let you get by with 0. What you technically have to do, and since this is being recorded, that means it's in the abyss for eternity. In AP Calculus, you have to round to at least 3 decimal points. Let me say again, my favorite number is 3. You have to round to at least 3 decimal points. Kaya, what's my favorite number?
3.
And how many places do you have to round?
3.
Correct. See how that works so nicely? So now I'm going to go to Shift G solve, and I'm going to look at my max, and I get a negative 8.472. And some people use a negative 8. I think I took a half a point. You have to give me a little bit more than that. Technically, you have to give me at least a negative 8.472. So what I said is that y is an element of the reals. Actually, I think this is what I would do. I would go from negative infinity to a negative 8.472, and from 0.472 to infinity. That's how I would have done that. This is a composition, so you had to put x plus 2 in there and square it, and then add 1, and that should give you x squared plus 4x plus 5, I believe. So what I did in my head, I get x squared, I get 2x twice, because the outer and the inner are both 2x, and then square 2 and get 4 and add 1. Again, this is going to be all the reals. And then I went back and graphed this. I didn't, I used calculus, but we can. And I'm going to put in type, and I'm going to put in x squared plus 4x plus 5, draw. I got a minimum, so I'm going to find it, and I get 1, so that means I have to be 1 to infinity. Any clarifications on A through F? All right, next page, find the intercepts. Well, the first intercept I find is the y-intercept. So if x is 0, I get 0, negative 12. I got to make sure I put that down. Then I have to make, so this is on the y-axis. Now I'm figuring out what's on the x-axis. And on the x-axis, y is always 0. So I'm going to factor. And I got x minus 4, x plus 3. That means I get x equals 4. I get x equals a negative 3. So my intercepts are 4, 0, and negative 3, 0. And I have 3 of them, so it's worth 3 points. This one is points of intersection. So what I did here is, I believe I solved for y. So I said y minus 1 equals x. So I had y minus 1 is equal to y squared minus 3. I made it equal to 0. And I get y squared minus y minus 2. And that factors to y minus 2, y plus 1. And that means y equals 2. And y equals a negative 1. And it asks for points, so I'm going to write them as points. And this is going to be 2, and this is going to be a negative 1. And if I plug in 2 here, x gets to be 1. And if I plug a negative 1 into here, I get a negative 2. And those are the 2 places that it intersects. Slope. So a lot of people said rise over run, that's fine. For me, slope is the rate a line increases or decreases. That's what I chose. A line passes through the point 1, 4, which is right here, and has a slope of a -3/2. So I was looking for a graph that looks like this. Write an equation of the line above. And again, since time is an essence, this is all I do. I write the slope, point slope form. So here's my slope. Now I'm going to put in my point, x minus 1 plus 4. Now, I always check. I know I got to pass through this point, so I substitute 1 to see if y is 4. Sure enough, when I get 1 in here, I get 0. -3/2 times 0 is 0 plus 4, y is 4. That's how I check. Some people wrote this as an answer, which is perfectly a-okay. We're going to be using this form a lot, and you're going to end up doing some work in which you have to move forward to the other side to solve. I just think it's, and so you'll see me write it this way all the time to avoid doing extra work. If you put it in slope intercept form, there wasn't anything wrong with that, but here's the problem. When AP corrects your test, they will look at your final answer. And so if you had this correct and then decided, I'm going to get it in point slope form, and you did this, that's the wrong answer. This was the right answer. I made a mistake over here. I forgot the 2. Divide by 2. They will give you no points for all that work. So I simply stop here and I don't simplify because 1, I'm highly stressed. 2, I only have so much time and I don't need to go any further. Okay. And you'll hear me say that over and over and over and over. What's the slope? I took m equals 8 minus 1, subtract my y's. Now my corresponding x's. And I got 7. -1 minus a -3 is a -1 plus 3. I get 2. Here, I'm going to just show you, this is how I do it. This is a -1. I have to divide this by 3, so my slope is a -1/3. This is not slope. That x means now you have an expression, which is not slope. X is your input number. What if I made that 15? That's not the slope. The slope has to be a number. The y-intercept. So I made, what did I do here? I got 4y equals a -x plus 8, and I divided by 2, and so I said my y-intercept is equal to 2. I just divided 8 by 4. What's the equation? So here's the point 7, 2. So here my slope is a -3, so I wrote a -3 times x minus 7 plus 2. Again, I check. If I plug 7 in there, will I get 2? Yes, I do. A slope of 0 is a horizontal line. Here's my point. Notice it passes through the y-axis, and y is always 2, so y equals 2. Undefined is a vertical line. It passes through the x-axis, so x is always 2. Again, I need slope. So this time I took 23 minus a negative 7 over a negative 18 minus 18 is 30 over a negative 36. I simplified that. You did not have to. I got negative 5, 6. And so I simply said y equals a negative 5, 6, x minus 18 minus 7. And then again, I check. If I plug 18 in here, will I get a negative 7? And I do. This time once it's parallel, so I'm going to figure out this slope. I get negative 5y is equal to 2x plus 9. That means my slope is a negative 2/5. So I'm going to have y equals a negative 2/5, x minus 3 minus 4. Again, I check. If I plug in 3, do I get a negative 4? And I do. Number 12, I get y equals a negative x plus 5. It's perpendicular, so it's the negative reciprocal. The reciprocal of a negative 1 is a negative 1. The opposite of that reciprocal is 1, so my slope is 1. So it's y equals 1 times x plus 6 plus 4. I check. If I plug a negative 6 and I get 4, I guess I did do this as 10, but you could have left it like this. Any questions about that page? Okay. Okay, it wants x to be the number of miles, and it says C's got to be in terms of dollars, and this is 45 cents. Now it's $0.45 plus, and it's dollars per day, the daily cost, so then I'm just going to add 175. A function is a relation or a set of points where each input, remember the domain or X or whatever you want to say, each put has exactly one output. This one right here, this is a parabola that goes down, and it's a negative x squared plus 4. So here's 4. I'm going to have an open circle. I put in some numbers so I could at least get a decent one. If I put a negative 1 in here, because it's got to be numbers less than, I'm going to get a 3. And if I put a 2 in there, I'm going to, excuse me, a negative 2, I'm going to get a 0. So here's my parabola that goes like this. And then the y-intercept here is 2, and I'm included here, and the slope is 1. And so there's my graph. And it says evaluate this function at 5. I don't even look at this because the only inputs I'm allowed here are negative numbers. And that's a positive number. In fact, it's bigger than 0, so I'm going to use this here. So I have 1/2 times 5 plus 2 f of 5. My only answer can be 4.5. That's it. It cannot be any other answer. And sure enough, it would hit 4.5. This is, so I have to figure out what g of 2 is. So I put 2 into here, and I get pi over 2 times 2, and I get pi. And then I have to figure out what the cosine of pi is, and that's a negative 1. This is absolute value shifted over this way. If I put a -1, I'm at 0. If I put in 1, I'm at, excuse me, if I plug in 0, I'm at 1. If I plug in 1, I'm at 2. If I plug in 2, I'm at 3. If I plug in 3, I'm at 4. You didn't have to do all those numbers. That's just me being nuts. If I plug in a -1, I'm at 0. But if I plug in a -2, now I'm at 1. If I plug in a -3, I'm at 2. If I plug in a -4, I'm at 3. It's the big V. This is not absolute value. This is step. And if I'm at a -2, it's a greater integer function. In fact, if I'm at a -2 to a -1.9, because it says, okay, what's the greatest integer you get that doesn't exceed, that is less than this number? Well, -2 is less than a -1.9. And so it looks like these steps here. Expand this. This is x times x squared. A -3 times x is a -3. There's 2 of them, a -6x. A -3 times a -3 is 9. Okay. This one you could have multiplied out. It is not x cubed plus 1. That is wrong. It's x plus 1 times x plus 1 times x plus 1. But if you know Pascal's triangle, I know that it's x cubed plus 3x squared plus 3x plus 1. So that's what you get when you multiply that out. Nobody got number 22 correct. Some people got close. If this is a function, here are my input values. So it's going to be x plus h squared minus x squared over h. This is equal to x squared plus 2xh, because x times h is xh and h times x is xh, and you got 2 of them, plus h squared minus x squared over h. I have a little removal to have going on. So now I have 2xh plus h squared over h. I can factor out an h. I get 2x plus h over h. I get to do that one more time. And I get, as a final answer, 2x plus h. All righty. So that's it. Now, if you want to privately chat with me, how in the heck does that happen? Let me stop sharing. Might be easier. You can do that. Otherwise, I'm going to keep this open. Today, by the end of the period, your 2 assignments which are due are the 2 sheets of paper, the limit worksheets on tables and the limit worksheets on graph. Am I correct on that? That's due at the end of the period. And so you can work on that, and you can submit them. It works better. I guess it doesn't matter how you want to submit them. You can submit them on, you can either email them to me or you can submit them by email. I don't care. And then otherwise, I'm going to correct and get homework in, because I'm way, way behind in homework, and that's going to change your grade vastly. So remember that I drop the lowest grade. Okay. I got another story to tell, and you'll hear this again. Okay. When I was in college, I took a class. It was called linear algebra. And I took it from my favorite teacher, Dr. Tom Richard, and he was fantastic. He was great. And we took a test at the beginning, and I hadn't studied for it because I thought I knew everything. And he wrote all the grades on the test. And when I got my up on the board, I got a 32%. The next highest score was 80. I'll never forget that day. And so, I mean, I was going to quit school because I had never experienced that before. And it's probably the most important test I ever took. And he had the policy where he dropped the lowest test score. And I thought, thank God. So that's just, and I'll probably add to that story more on and on, but I almost dropped out of college because of that. So I'll keep this open. If you go through your test and you want some changes, just do a private chat. It'll probably pop up for me. And then I'll take a look and we can come up with some idea. Okay? Otherwise, you can give me a call on my cell phone at another time, and we can work on that. Does that sound okay to everybody? Christian, does that sound okay to you?
I have a question.
Okay, this is whom?
Cora.
Cora. Okay, what's your question, Cora?
On Schoology, it said the homework is due on 11:59 tonight, and so that's what I thought.
Oh, okay. If that's what it says, I will keep it that way. Does that work?
Okay, yeah, thank you.
Yep, I will do it that way. Okay. And maybe that's what I thought. And then sometimes I can't remember what I thought and stuff just comes out. So yeah, I will keep it till that time. Okay. Oh, I want to talk about something else. If some of you are starting to work ahead, I'm going to modify the homework 1-3. In fact, I'm hoping to do it just in a few minutes. I'm going to take out the problems that deal with the formal definition of a limit, and I'm going to move it to next week and make it part of the 1-4 assignment. So you'll still have to do them, but you're not going to have to do them by Monday. Does that make sense to everybody? Because I'm not going to talk about it till next Tuesday. One, I wasn't able to make the video, and I think I really want to rewrite my notes. I wasn't happy with how I talked about it yesterday. And I think when I looked at you, I saw this glaze of fear about it. And so I'm going to spend the weekend redoing it. And it'll be a lot better on Tuesday when I do that. So in a second, I'm going to do that. Darcy, are you all for volleyball?
Yep.
Are you excited that it might be brought back in October? They're making that decision today. Do you know about that?
No, I didn't.
Oh, okay. Yeah, they might start up the volleyball season. Who's your volleyball coach?
Beckman.
Oh, okay. All right. Ask her about it. I don't know. Okay. All righty. I am going to check a few things and make some changes, but I do have a few questions I got to check. Okay.
I had a question on the worksheet.
Yeah.
I know for question 3 on this, like the third question for the first worksheet, the first one on the Segnet page, and then also the 5th one on the back.
Yeah, let me get my act together here and find. You're saying the orange one, correct?
Mm-hmm.
Okay, where are my orange ones? All right, let me share the screen with you.
I know for that one, my
Okay, so
calculator.
which one am I looking at? Number 3?
Yeah, the first one on the Segnet page.
Okay,
My calculator had divided out the 0, and so I just ended up getting a straight line at sign, and I got the same thing for 5 on the back, and I wasn't sure if that was right or not, or if that
so
was
you
just
made
saying
you made a table?
Mm-hmm.
Well, okay. Do you have a TI?
I do.
And I'm going to share this with you in a second here. And are you in radians? You have to be in radians.
I believe I'm in radians. I'll check.
Everybody must turn to radians. I gotta make sure this one is. That is.
How do I make sure I'm in radians?
Go to mode.
Okay, thank you.
You see it now?
Mm-hmm.
Okay. Okay, so here's my calculator. Okay. And it says to put in a -0.1. And so I'm thinking it's headed towards 1 already. So I'm going to put in a smaller number. Ooh, it's even getting closer to 1. In fact, it says 1 there, so it must have rounded to 1. Do you see that? And if I plug in 0, it's going to be undefined because I'm dividing by 0. So there should be a dash there.
Okay.
Does that make sense?
Mm-hmm.
Okay, and my guess is if you come, so that's coming from the left. My guess is you come from the right, you're probably going to get the same type of answers. Yeah, that looks pretty close to 1 too. Okay,
Okay.
that answers that.
Mm-hmm. I was also wondering, for the one below it,
Yeah,
the values we should put in for the x.
you get to decide.
Okay.
So you're going to pi, correct?
Mm-hmm.
So I would probably start at 3.1 and maybe 3.11, right? You just want to make sure you're smaller than 3.1415.
Okay.
And then on the other side, you just want to make sure you're bigger than 3.1415. Okay?
Mm-hmm.
Wait, Mr. Kruger,
Yes.
how do you make sure you're in radians like on a Casio?
So you go to, I believe, shift menu is set up. Do you see that?
Oh yeah, I see.
Okay, and if you scroll down,
On the degree one or angle.
yeah, and then you're going to choose F2.
F2.
Yep. And if you want to make your life really, really easy, go back up and there's a thing that says derivative. Do you see it?
Yeah.
Make sure that's on. You're going to really like that.
All right. Thanks.
Ella? Okay. I got you. Okay. Alrighty.
Mr. Kruger, I have a question on limit worksheets using graphs on the last page.
Okie doke.
Letters K and L.
K and L. Yes. G of 0. Correct?
Yep.
So if I see G of 0, that's where it's going to cross the y-axis. Would you agree with that?
Mhm. I would, yep.
That is my third favorite letter of the alphabet. Does that make sense?
Uh-huh.
Yeah, it could have been written a little bit nicer, but I didn't write this word.
Yeah.
Okay.
Okay.
And then you said L.
Mhm.
Okay. So now you're approaching 0, correct?
Yep.
Okay. And if you look at where 0 is, it's continuous, right?
Mhm.
So since it's continuous, actually it's continuous from B to C, right? B and C must be asymptotes, correct?
Yep.
Okay. Well, excuse me, maybe not. I think those dotted lines aren't asymptotes because there's values on them. So between B and C, that the graph is continuous. So the limit as you approach 0 is going to be the same as G of 0. Does that make sense?
Yeah.
Okay. Does that help?
Sounds good. Yep. Thank you.
You're welcome. So I made adjustments to the 1.2 assignment. I took out the last two problems, which are 33, 34. They'll be moved to the 1.4 assignment, which won't be due till the next quiz. So that gives me some time to properly explain it to you, and you have some time to work on those kind of problems. So just wanted to, I sent an email also detailing that, but I figured I just might as well say that. Okay, that's the end of the class. You guys, as usual, were wonderful. See you tomorrow.